So, hello everyone. Today I will present you the work that the paper that was accepted for this DFDS conference, which is about the proposition of a classification model for the different automated tools. This is a work that I've been doing with Frank Breitinger. But first, before going into that topic, a few words about me. So, as Chris introduced me, I'm Gaëtan Michelet, and I'm a PhD student in digital forensics. So I've been doing my PhD since September 2021 with the University of Lausanne, and I'm currently affiliated with the University of Augsburg starting from today. So that's quite a nice first day. And I have a strong interest for automation applied to digital forensics and how we can leverage artificial intelligence to automate some stuff for digital forensics. So my PhD is about trying to push forward the automation of the reporting phase. As you know, you can divide the investigation into 4 phases. There is the acquisition of the data, examination, analysis, and reporting. And from what I could see and read, most of the automation has been focused on the 3 first phases, and there are pretty much nothing for the reporting. So this is what I wanted to contribute on. And currently, I have 3 projects that have been accepted. The first one, we proposed a definition for automation that was tailored for digital forensics. We will see it afterwards. Then there is this paper, which is about how can we classify different methods, different tools that automate digital forensic tasks. And I also, here it's more related to the reporting phase, tried to use some LLMs to generate some sections of the reports and evaluate them. It was okay-ish, but not very good. And there is an ongoing project where I fine-tune LLMs to improve it and to see if we can make it better, and it looks like it's the case. So this is the definition that we proposed. There are 3 key elements that I will point out. The first one is the fact that it can be either a software or hardware. Usually when you think of automation, it's more software, but it can also be hardware. Then you have the goals of automating something. So it's to become more efficient, more reliable, or more transparent. Usually you will not achieve the 3 of them, but if you have at least one of them that is achieved, it qualifies as automated. And finally, there is that idea of reducing or removing the human engagement. We are not trying to really remove the human out of the process. So even if you only reduce a little bit the engagement of the practitioners behind, it qualifies as automated. But now if we take 2 very different methods, so the first one is a file system parser, very basic one, that simply follows the file system documentation, and that will present to you the files and the folders that were created by the user with the associated metadata. We can see that in that automated tool, there is not much decision involved. It's simply following a process and presenting you some data. So given that there is no decision made, the amount of risk that you take when using this tool is quite limited, but it also limits the capabilities, meaning that if you have a new file system or if you have a corruption into the data, it will not be able to parse it correctly. This is still useful, but it is quite limited. Then we have a second tool that is leveraging artificial intelligence to identify relevant evidence. I'm not sure this actually exists, but if we take it like as something that exists, it can be using machine learning to identify the relevant evidences. Given that it's based on the learning process, it will make some decisions. So you will have some risks. The tool can make mistake, or it cannot correctly identify something, or maybe it can tag something as irrelevant, even though it would have been important for the investigation. So you have risks, but it also brings some more capabilities, and it can have a bigger impact on the investigation. So the problem is that if we take the definition that we saw previously, both these methods would qualify as automated tools or automated methods, and they are really different. We considered 2 key elements. The first one is the capabilities with the underlying impact on the investigation. And the second one is the amount of risk that you take while using them. And we think that having a quick insight over those two elements is quite useful for practitioners and also academics. And to solve that problem of making differences between those two methods, we proposed a classification model. So there have been already some work since 1990, so quite a long time ago. And it started with industry and spaceship vehicle and how they are automated. But it does not really apply correctly to other fields and for us in digital forensics. So very often, people simply took existing models and they adapted it to make it fit better their domain. And this is pretty much what we did with this model. So we started by exploring different categories. The four most interesting that we identify are the following. So the levels of automation, which provides information about the autonomy of the tool, how autonomy is achieving stuff without human intervention. Then there is the complexity, with the assumption that the more complex a tool is, the more capabilities it will have, but also the more risky it will be to use it. It's not always the case, but that's like what will be the case most of the time. The problem with that category is that it's quite difficult to quantify the complexity of something. So yes, it's a bit difficult to use. Then we have the impact on the investigation. Once again, it's very useful because it provides a good insight for the practitioners, but it's very difficult to quantify. You can also have some tool that will be very useful in one case and that will have no applicability in another case. So very difficult to use. And finally, we have the decision-making process. So what kind of decision is the tool or the method able to do? And the second element that we consider is the dimensionality of the model. As we could see, we saw four categories. We can use one, and you have a very simple model, as we can see here. But you can add more categories and just increase the dimensionality. It's good because you add some more granularity into your model. So if you have, for example, two categories with 5 classes each, you would have, in the end, a model with 25 possible classes for your tool. But if you keep adding dimensionality, you will lose a bit the usability of the model. It will be difficult to represent, very difficult to use for practitioners, and it will lose its purpose because it will never be used by anyone. So this is our suggestion. We suggest a two-dimension model with the level of automation and the decision-making level. Level of automation, you can see the first one is the manual level. So there is absolutely nothing automated. The practitioner is doing everything by hand. Then you have two levels with assistance, where a few operations are achieved automatically. And then you have task automation, where you have part or a complete forensic task that is achieved. So the difference between assistance and autonomous assistance is that in the first level, the practitioner will launch the tool. And in the second one, it will be launched automatically once a condition is met. For example, you can, if you load an image, once the parsing, the file system parser module is finished, it will go extract the WhatsApp database and show you the 10 first messages, for example. And so that's the difference between the assistance and autonomous assistance. And the difference between partial task automation and full task automation is that partial task automation achieves a part of a forensic task, and full task automation achieves a complete task. A forensic task, for example, could be identifying all the relevant textual documents in a file. We will see how it applies after that. Here there might be some troubles making a good distinction between a complex set of operations. So, for example, autonomous assistance that is quite advanced, and the partial task automation. When you try to classify a tool or a method, you have to keep in mind that the important element is the magnitude of workload that is undertaken by the tool. But we recommend that if you hesitate between the two, you go for the partial task automation. And for the decision-making level, the first one, no decision, so simply a process that is followed. Objective decision, on that one, it's a simple comparison that is used, for example, for filtering a date. Subjective decision, it's a decision that is based on a set of rules, that was created manually by the practitioners, and also some input data that is provided to the tool by the practitioners. Finally, you have the learning decision. Here, you provide a data set and you use a machine learning algorithm. So it will create the set of rules automatically, and you won't know it. And finally, full decision. It's the same as the learning decision, but this time we trust the tool and we do not control what the output is. And so here is the model with examples. We will not go over all the examples. You can find it in the paper if you're interested. We will just go over a few of them. First one, you manually select some files that were created at a certain date. For that case, you are applying a filter. So you are just making like some simple comparisons. So we are at the objective decision, and you do it manually, so there is no automation. Second example, you search a list of keywords that was generated based on the crime that is investigated. In that case, it will take as input the crime investigated that is given by the practitioner, for example. Then it will follow a set of rules, provide a list of keywords, and then it will search for these keywords. A third example, yes. So this is the subjective decision, and it's assistance because it's only a few operations that are undertaken by the tool. Here we have a partial task automation. It is clustering some textual documents based on a clustering algorithm. And so it's clustering the documents based on their topic. Here it's partial task automation because the underlying task is identifying the relevant textual documents. And here it's just clustering them together, but a practitioner will still have to go into each cluster and see if this is relevant or not. So it's not a complete task automation. And of course, it's a learning decision because it's based on a machine learning algorithm. And finally, we have the classification of an executable file as malicious or not, based on a classification model. So once again, we have some machine learning involved, so it's a learning decision. And we can consider that identifying if an executable is malicious or not is a forensic task, and this is why it's full task automation. So that's a working model. We know that it is not perfect, but we wanted to present it to you just to get some traction and maybe have some discussions and improve it. We know that it needs a bit of refinement, and this is why it's nice that we have the opportunity to present it here, because we can gather some opinion and some feedback from other academics, but also from some practitioners. So if you have any feedback or any idea, don't hesitate to tell me during the question session or afterwards. And so, yeah, that was for the paper. And just for the next steps of my PhD, I would like now to use that classification model for a systematization of knowledge paper that will target the automation for digital forensics. So I will use it to see how it's distributed between the different classes. And I will also investigate some other questions. And for the report generation, I would like to incorporate some human evaluation because right now it was completely automatically evaluated using automatic scores, but it's a bit difficult. We will get some challenges because there are lots of text to analyze. And if you want to evaluate a report quality, you need to have some expertise. And I'm also considering comparing the LLM to other text generation methods just to see how it performs. So thank you. If you have any question, I would be happy to answer them.